Hi friends, welcome to this session. Are you looking for a solution to upload very large files which are in gigabytes, even in terabytes? Did you ever consider a object storage for upload solution? Here we are going to talk about a solution which we implemented at NetApp which covers both. My name is Murthy Patnaik, working as an architect at NetApp, building a robust and scalable tools around NetApp products. The business problem what we are going to discuss today is we need upload solution which can support a large files. The average core file size is at core file size is 150 gig in NetApp, which is estimated to grow up to 800 gigabytes. The application should be a secure, reliable, and scalable, meaning it can support a multi-region presence with a global high availability, and the pause resume feature because the customer doesn't need to sit in front of the machine to upload any large file. So whenever he has a time, he can resume the upload, he can start the upload. And the key issues what we have currently today is legacy upload solution is supporting up to only 25 gigabytes, and also it's a slow upload rate, and it's a main pain point is it's a UDP based application which requires a special firewall ports to be opened at a customer site, and also the plugins need to be installed at the customer site, which many customers are not willing to install any plugins. The agenda of this the complete session is the first one is geographic landscape, where we had presented this upload solution last year inside with three on-prem storage grid locations in North America and EMEA. How we expanded our solution to the rest of the world. So I wanted to showcase the geographic landscape of our upload points, and also followed by there is a quick demo where you can see the current application, how we implemented, and what is there currently in the upload.netapp.com site, and the application architecture, the architecture overview, and how we implemented the solution, how we expanded the solution to the public cloud offering like AWS and Azure. And once the object is there in AWS and Azure, how we sync the object between the public cloud to the storage grid. So the geographic landscape, as I mentioned in last year insight, we mentioned we have three upload points actually. So all three are NetApp data centers where we have a US East, West, and EMEA presence. We have three endpoints in a drop down. They can upload any file to the all three locations. Based on the customer demands across various geographic locations. So the three endpoints are like not able to serve the whatever we achieved the upload rate. So the reason the same reason we expanded our solution to include AWS locations, right? So we can leverage the AWS landscape, and we can take the upload from the AWS location, and later we can sync that object to the NetApp StorageGRID. So we started with the Sydney AWS location. That's a simple S3 bucket, and later we expanded to the Tokyo, Hong Kong, Mumbai, Singapore. So the same way we expanded our solution to the 8 AWS locations. AWS locations in the sense AWS S3 locations. So once the object is completely stored in a corresponding region, so we'll sync that object back to the North America for further processing. So here we implemented so far for a AWS location. Soon we are going to expand this solution to the Azure locations wherever appropriate, so that we can call this solution is a true hybrid cloud. So the quick demo, so if a user types upload on NetApp.com site, it's behind the firewall. It's a secure. Only NetApp authorized users only logged into a system where they can upload a file. Right. Once they land on the home page, they can see the case number, the form, case number, and a closest region. The case number, this should be a valid technical case number the customer enters. Once the customer enters a case number, we are going to validate against our NetApp and whether that's a valid and open case. Once the case is validated, we'll enable the drop down, right? The drop down has a list of sites. Along with the NetApp 3 sites, we show the remaining AWS locations also, and also this drop down is sorted based on a distance of the customer login. Right, so I logged in from a East Coast, so that's where I think the East Coast option comes first. Let me open a developer tools so that you can see how we are ingesting an object from browser to the storage grid. Right, if you select a file, I'm selecting a 1 GB file. So once I select a file, it start upload, right? So now there is a validation, right? Whether the file is already uploaded to the NetApp or not, right? So if the object is there already, then we'll show the options for the customer, whether they wanted to do the new upload or they can start from, they can resume it, or they can start as a new upload. So now upload is in progress, so they can pause the upload and let's pay attention to the actually how we are sending, right? So the upload will be sent to the server through a presend URL. So I'll talk little details on the presend URL, why we are using a presend URL, and also there is a metadata field. Right, the metadata, I think whatever you are seeing, right, part number, and the upload ID, and there is a file name. So you can attach a metadata up to 2 KB of size. So we are strongly relying on the metadata feature of the StorageGRID, where you can add a bunch of information to the metadata, so that it's a very easy to query metadata than a file. For example, if you want to download any object before any check, for example, I want a certain case number uploads, or I want a certain file names, right? So you can query the metadata. Getting a metadata is a quicker way because you can download just a 2 KB, and based on the metadata you can start invoking the actual file upload, which is in a gigabytes, right? So that way I think using a metadata you can improve the performance of your upload solution. Right, so here upload the complete upload is 100% complete. So once the object is there, right, so that whatever the object I uploaded, it's there in the North America East actually. So we have a StorageGRID in East. The object is ingested there. Once the object is ingested to the StorageGRID, so we'll have a notification event notification, where our download jobs are listening to the notification, and once they get a notification, download scripts start download from the StorageGRID directly for the further processing. The application architecture. So this is what we presented last year inside. So we have 3 sites: US West, East, EMEA. The US, for example, if the customer chooses a 3 upload location, any 3 upload location, and we have a corresponding StorageGRID locations, in each region. So once they upload, once the object is there in a corresponding storage grid location, so the storage grid will send an event notification through Amazon SNS. We use Amazon SNS for the event notifications. Once we have a notification, our download servers, we have one download server in North America and one download server in EMEA. So based on the event notification, our download script start download from the storage grid directly, right? So as you see in a demo, it's a secure, right? It's behind the NetApp SSO, and it's a pure TCP based solution, and it doesn't require any client-side plugins because it's not a UDP, right? It's a faster, reliable file uploads and supports up to 2 terabytes. And also it's a secure S3 based HTTPS solution, and it supports a multipart feature, right? Multipart upload is we'll talk little details in the multipart. The reason multipart is it's a faster way to upload any large files to the storage grid or any S3 aware object store, right? So and also it provides a great facility, like for example, whenever you want, you can pause it, you can cancel it, you can resume it, right? So using a multipart, it's easy to handle such scenarios, right? And also we used a present URL for added security. I just showed you how the present URL looks like. The present URL will be generated for each part we trigger to the storage grid. So the and also the present URL will be valid for only certain duration. So it's a added security. And also it's a fast and easy to implement. It's we built this solution with a well-known tech stacks like S3 SDK, Angular, and Node.js. And you can use a Boto 3 also. This is completely because it's completely S3 based solution. You can implement easily with a well-known tech stack. So the implementation details of the multipart upload, right? As I told you, the best way to upload large files in a fast and reliable manner is through multipart, right? So it can be used for stream uploading. For example, I have a 1 gigabyte file split into smaller chunks. So for example, if I select my chunk size is at 100 MB, so it splits 100 meg chunks and send it to the storage grid. Once you send it to the storage grid, so the storage grid automatically merge all the chunks once all chunks are received by storage grid. And suppose if you use a get object on it, it automatically merge all those parts into one and start download as one file. So the advantage with the multipart is for example, you have 100 chunks, for example, right? So for example, 98 chunks got successfully uploaded, only 2 chunks got failed. So only thing is we need to re-ingest only those 2 chunks to the storage grid. This will eliminate for example, if the 2 chunks got failed, we don't need to upload all 100 chunks again, right? So we need to retrieve only those 2 chunks. It's easy to manage. And also, for example, if you pause it, for example, if you pause it at a 50th part, so if the customer resumes it, so you can start from 50th part onwards. So it's easy to control the pause and as well as the retry if in case of a failure. And the present URL can be accessed without a credentials for a predetermined period of time. As I said, for example, I have a 1 gig file which we chunk into multiple chunks, like maybe 100 meg parts. So each part will generate one present URL, right? So the present URL can be generated using multiple parameters like a bucket name or a file name, and we can set a expiration. Here I'm setting a 6 hours expiration. So you can set a 1 hour expiration or a 5-minute expiration or 24-hour expiration, right? So you can set a expiration for the URL. Once if the time passes beyond 6 hours, it automatically gets invalidated. You don't need to invalidate that URL actually, right? So once the present URL is generated, each present URL will be a unique for each part, right? So once you have a present URL, each part will use that present URL and send directly that part to the storage grid, right? So that this is a added security we implemented using a present URL. And of course everybody knows this one, AWS credentials, right? For example, in order to access any S3 ever storage, for example storage grid, you need a access key and a secret key, right? So the we don't store this access key, secret key in a code actually. So we maintain it in a system variables or AWS credentials inside this server. So whoever have a sudo access, they can access to these keys. Other than that, I think no one will have access. This is a best practice I think I wanted to highlight. The multipart upload, once we have a URL for the present URL, so you can specify a part size. For example, the part size is, for example, 100 meg, right? So and also max upload retries for each part. For example, we configured as a 3. So it means that for example, if any individual part got failed, it retries for 3 times. After that, it's even after 3 times it fails, then we mark it as a failed state for the entire object, right? So you have a capability to retry at each part level, right? So and once we set the everything, and you have a present URL, you have a part, so all you need to invoke is the S3 API call to upload a part, right? Once you upload a part, that will automatically ingest the corresponding part to the storage grid, right? So this is what we presented in last year Insight. This year we expanded our solution towards a hybrid cloud. So the why we expanded hybrid cloud architecture is, there are customers who are at the very far from all 3 geolocations what we discussed so far, like in North America and EMEA, right? The customer demands from multiple geographic locations with high latency. For example, the customer sitting in a Sydney, so he has a high latency to the US East or maybe EMEA, right? So we cannot improve the latency, right? So but we can localize the grid so that we can faster the upload. And there is a low bandwidth network, so that's also another pain point currently with the just 3 on-prem grids. And it can coexist with any cloud providers, because we can leverage AWS and Azure landscape to take the localized file upload and ingest it, right? So I'll show you, and there is a the easy integration. For example, AWS and both StorageGRID and AWS follows the S3, right? So whatever APIs we write, it's a seamless between these 2 endpoints. The only thing is you just need to change the endpoint only. The remaining code base, everything will remain same. But keep a note here. So the Azure is the blob storage, so we need to have a separate code for that ingest the object into the blob storage. Once you ingest the object into the blob storage, then afterwards I think we use a NetApp CloudSync actually, so to download or sync that file to the storage grid. So we are going to talk about all this in next slides. So this is what we have seen in the previous slides. So how we implemented 3 sites, how we expanded this application towards a public cloud. right? So this is what you saw this all these endpoints, AWS endpoints in the drop down. We already implemented in our production site. So we have 8 AWS locations. Once the customer picks AWS location, that object is stored in a AWS S3 bucket. Once the object is there in S3 bucket, we use a NetApp CloudSync to sync that object into the StorageGRID. This is a seamless NetApp CloudSync. We don't need to write any code. It's just a configuration where you can configure routes. So we'll talk about briefly on the CloudSync in the last slide. So the only thing is you need to configure a source bucket to the target bucket. It's between the StorageGRID to the AWS or AWS to the StorageGRID. But we are syncing from AWS to the StorageGRID. Right, so this is what we implemented. So our focus is to expand our solution to the Azure also wherever is appropriate, to make our solution is a true hybrid cloud. Once for example, if the customer picks a Azure location, the object is stored into the Azure blob storage. Once the object is there in Azure, so we'll same thing, we'll ingest that object, we'll configure a cloud sync between the Azure to the StorageGRID. The same way you need to configure another route to sync between Azure to the StorageGRID. So the NetApp CloudSync, right? The NetApp CloudSync is it's a plain way. You don't need any coding for it. You can sync between a public cloud to the StorageGRID actually, right? Or sync between public cloud and StorageGRID, or StorageGRID to the public cloud. Right, so our use case mainly uses AWS East to the StorageGRID and Azure East to the StorageGRID. Right, so it's a any cloud to any cloud. You can see in the diagram. So you can pick whatever the cloud solution you can put as a source or a target, and you can configure a route, and it's a configurable sync schedule. So for example, you can configure a daily, hourly, or at a minute level actually, right? So for example, as soon as I have an object in AWS, so I can configure a sync. For example, if we configured 5 minutes as a schedule, for example, right? So whatever the object is there in AWS, for every 5 minutes our CloudSync will sync those objects, the objects to the StorageGRID. So it's a seamless, and within a 5 minutes duration, we'll see all the objects which are uploaded, all the 8 AWS locations to the StorageGRID. Yeah, this is what we wanted to show in this presentation, and the key takeaways from this session is how we used a NetApp StorageGRID to build highly scalable solution for very large file uploads, how event notification work across multiple sites, and how StorageGRID coexist with other public cloud solutions, how CloudSync Cloud Mirror fit into the solution. The Cloud Mirror, what we used, right? So in EMEA, StorageGRID is a isolated StorageGRID, so it's not a connected grid. So because to reduce the network choking, so we set as independent grid in EMEA. So once if the customer upload any file to the EMEA StorageGRID, once the object is completely uploaded to the EMEA, then we are using a Cloud Mirror to copy corresponding object from the EMEA location to the North America. So for that we used a Cloud Mirror. So we presented in last year Insight. These are the related sessions related to the StorageGRID. Maybe you just pay attention and attend if you are interested. And these are some of the IT related sessions. You can, for example, if you want a customer one meetup, so you can register at netappit.com. It's scheduled on November 5th at 10 a.m. EST. and stay connected. So we have a follow us on Facebook or at Twitter. Our handle is NetApp Insight. Yeah, we value your feedback. So please drop your feedback through survey. Thank you. Thank you for attending session. Stay safe and stay healthy.